Now we're going to take a look at how the mole relates to mass, because often we don't have to sit there and count the number of atoms, or I don't care about how many atoms there are or how many moles are in an atom. I don't use that number ever. We use grams. If I'm going to go to a lab experiment and I want to weigh out this many grams, it is good to know how many moles that is. So I have these two vials. When we looked at these before, this one is my potassium dichromate, this one is copper. Copper is 63.55 grams per mole, and potassium dichromate is 294.22 grams per mole. Notice how they are both a mole with the same number of atoms, but they weigh different amounts. They look wildly different and they weigh very different amounts. Well, that works just like the way that if I have a dozen eggs, that does not weigh the same as a dozen pencils. Both a dozen, both represent 12, weigh completely different amounts. You're not going to tell me a dozen apples weighs the same as a dozen oranges. Not going to work. So, what we have to look at then is how many grams are in 1 mole for each substance. And that is what we call a molar mass. Molar mass is the number of grams per mole, or the number of grams in 1 mole. And when we look at these grams per mole numbers, or these molar mass numbers, they're actually located on your periodic table. We used to call them the average atomic mass, and we measured it in AMUs. Well, an AMU is the same as the grams per mole, so I can look just on my periodic table and look for copper, and it says 63.55. Well, AMUs, or 63.55 grams in 1 mole. When you look at converting these numbers, think about an ordinary unit. So if I have 5 dozen jelly beans, and I want to know how many grams that's going to be without having to weigh it, I would have to know how many grams per dozen the jelly beans weigh. Well, if somebody told me that there are 35 grams in 1 dozen of jelly beans, well, all I would do is take 5 times 35. And that's what you do, and I'd have 175 grams. So without even counting them, I would know exactly how much 5 dozens should weigh. Let me do the same thing with the mole. And if I'm going to say that there are this many moles, all we do is multiply by your molar mass. And that'll tell me exactly how many grams I have without having to count it. Now that we looked at the ordinary unit, let's take a look at our moles and grams examples. So if I have 3.57 moles of Al, and remember Al is aluminum, if I want to figure out how many grams are in there, well, I need to know how many grams are in 1 mole. I need to know my molar mass. Well, you get that from your periodic table. So I look over my periodic table, you find Al. Al is number 13, but I want the molar mass. So that's that 26.98. And write that as grams per mole. And since I have 3.5 moles, and there are 26.98 grams in 1 mole, we multiply. You can also look at it as a ratio. If you have 3.57 moles, and I want to know how many grams that is, well, I have 26.98 grams in 1 mole. Then you would still be multiplying, okay? And when I do that, I should get 96.3 grams. Let me do the same kind of thing for the next one. So go ahead, try the next 2, and then check your answer. So you should have gotten 1,200 grams for silicon and 203 grams for cobalt, taking the mole number times its molar mass. Now what about if we go the opposite direction? If I want to know the number of moles from their masses, well then it's just the opposite of what we just did. I have 25.5 grams of helium, and I want to know how many moles that is. I look up on the periodic table, and I see that there are 4 grams per mole. Well, if I have 25 grams and 4 are in 1, I'm going to divide. 25.5 divided by 4, I should get 6.38 moles. Again, you can just do a ratio if that's better. 25.5 grams. I want to know how many moles. That's equal to 4 grams in 1 mole. And you still would cross multiply, and then you end up dividing by 4. Because 25.5 times 1 divided by 4. Try the next two and check your answers and continue. So that section was for converting grams to moles and moles to grams for elements. Now we're going to look at compounds. When you run into compounds, you also have to look at then how much the compound itself weighs. I can't just look on the periodic table and it's not just going to tell me the compound. It's a periodic table of elements. So you have to do a little bit of extra work, but not a lot. What I'm going to do is find the molar mass of the compound. And what you do there is you take each individual mass and you add them up for a total. So if I have copper and chlorine, I'll look up copper and I'll add it to the chlorine. Now if I have, for example, CuCl2, which is copper chloride, I have 2 chlorines. So I have to multiply that chlorine number, that 35.45, times 2. Subscripts tell you how many of them you have. If I have more than one, I've got to multiply that mass by more than one. So let's take, for example, the KC2H3O2. And all you do is look on the periodic table for each one of these. So if I want to determine the molar mass here, I take K, look on the periodic table, and it tells me that it's 39.10. I look up carbon, and it's 12.01, but there are 2 of them. So I have to take that times 2. Hydrogen, which is 1.01, and there are 3 of them. So I times it by 3. And then oxygen is 16, and there are 2 of them, so I multiply it by 2. And then you take and you add everything up. So 98.15 grams per mole. That would be the molar mass of this compound. So anytime you take grams to moles or moles to grams per compound, you have to figure out how much the compound itself weighs. So I'm going to go ahead here and try this next one. We have strontium, Sr, N, and O. Now strontium is easy, just look it up on the periodic table, which is the 87.62, and there's only one of them. But then I have this NO3, which is in parentheses. And these parentheses work just like math parentheses, okay? So I have 1 nitrogen, but I have 2 of these NO3 groups, which means that I have 2 nitrogens, or 2 times, okay? 2 times 1 is 2. Which then also means that 2 times 3, I have 6 oxygens. So I look up nitrogen, look up oxygen, and then I add them all together. So now let's look at how to convert moles to grams and grams to moles. So if I have 3.25 moles of sulfuric acid, and I want to know the grams, well, I need to know how many grams are in 1 mole, which then means that I need to figure out how much 1 mole weighs. So I take 2 hydrogens, 2 times 1.01, 1 sulfur, which is 32.07, and 4 times the oxygen. I get a total number of 98.09 grams per mole. Now since there are 98.09 grams in 1 mole, and I have 3.25, I take 3.25 times 98.09, and that will give us our answer of 319 grams of sulfuric acid, which is H2SO4. You don't want to divide because I have 3 moles and I know how much 1 mole weighs. Okay, and I can't just look this up on the periodic table because it's not an element, it's a compound. You have to look up each individual part. So why don't you go ahead and try the last one. And you should get 0.728 moles. Now we're going to look at how to convert grams of a compound to the number of moles of an individual atom. So, first thing we do here is you look at the number of moles that you have. So if I have grams, I divide by a molar mass and get the moles. And then you look at the compound. And if I have, for example, like in the last one, I have PbCl4. That means if I don't know how many moles of chlorine atoms I have, I would take that number times 4. If I want to know how many moles of lead atoms I have, I would take that number times 1. Because there's 1 lead and there's 4 chlorines. So you take your subscript and you multiply it by how many moles you have, and that's how many moles of that particular element are in that compound. So let's take the last example. If I have 52 grams and I want to know how many moles of CO2 molecules I have, so I'll take 52 grams CO2 and turn it into moles. I got to figure out how much CO2 weighs, so I take 1 carbon and 4 oxygens, and we should get 44.01. And I take my 52 and I divide by 44 because I want to know how many moles I have, and I have 52 grams, so I should have just over a mole, which is 1.18. Now if I want to know how many moles of carbon are present, well, 1.18 moles of CO2, and there's 1 carbon, so times by 1. So there's 1.18 moles of carbon. If I want to know how many moles of oxygen there are, 1.18, and there are 2 oxygens. If I take 1.18 times 2, which is 2.36 moles of oxygen atoms. And that's all there is to it.